Hello, my name is Joakim, and about a week ago I posted a video of these effects that I created in Unreal Engine 4. I got requests on making a tutorial on how to make these effects, so here we go. I use 5 textures for this. You can either download the textures I use or make your own. A link to the textures can be found in the video description. Let's take a quick look at the textures before we move on. So this is the albedo map that I use. In the alpha channel I have a height map. This controls the how the water should spread over the surface. I also have a normal map for the ground, a mask for the water, and a normal map for the big waves, and a normal map for the small waves. Okay, so let's start making the shader. Okay, so we start off by dragging in our textures. We need the albedo map, the mask, and the normal map. We can start off by plugging in our normal map and move these two out of the way because we're going to need a lot of space here. So the first thing we want to do is to add a 1 minus node and invert the height map from the alpha channel. We then want to add this output with the mask's red channel. Then we add a subtract node, and we will be subtracting with time to make the water puddle grow over time. In the end we won't be using this, we will be using the blueprints instead. But for testing this works much better. So add time multiplied by a low value to make it grow a little bit slower, so 0.1. Then we need a frac node to make the whole thing loop. We then want to add a constant value of minus 1.2 and invert the time and then into the subtract node. This will be controlling the amount of water. Or actually, this will be controlling the amount of water, but this is the input for it. And then we want to multiply this output with a high value and this controls the how sharp the edge around the water will be. So water edge. Okay. As you can imagine, we now have very high values here because we multiplied with 40. So we have to clamp them between 0 and 1. If we take a look now at the clamp, if you have live nodes on, we can see that the water puddle is growing over time. Okay. So now we can make our first base color by adding a constant 3 vector and picking a color, a bluish color. You can't see my color picker, but pick one that you like. And then we want to lerp between this blue color and the albedo map. The blue into the B input and albedo into the A input. And the clamp node will be the alpha. Now we can test this out. So into the base color. And yes, we can see that the water is growing. It doesn't look like water yet. We have to make the same thing for the normal map, so let's do that. We'll be lerping this one into the A input, a constant 3 vector with 0, 0, 1 into the B input, and this will be the alpha. Then plug it into your normal, and yes, we have a flat surface. What we don't have is we don't have any opacity in the water. We can see right through it. So what we'll do is to multiply the clamp node with a value of 0.5, and now the water will be transparent, like that. However, we have the same specular and roughness all over the surface, so we want to change that as well. And also we want a darker color around the water to make it look like wet ground. So let me just comment a few things here. This is the water area. And now let's make, this is the color. Oh, that's not color. And now let's make the wet area. So drag out a add node, and we'll be adding with minus 0.2 into the A input, and the time, the inverted time, into the B input. Then we want a subtract node, and this one into the B input, and the height map combined with the mask into the A input. Now this will be the amount of wet area, just like we did here. And we want to do the same thing. We want to multiply it with a value, but this time a lower value, and we will call this transition. Okay, and then also clamp them and multiply them so we get some opacity. So 0.5 again. And now we want to move these around a little bit to get us some space and make the color bigger, because we want a brown color in here. So another constant 3 vector with a brown color. I want mine quite desaturated, but you can pick whatever you want. Even more desaturated. Alright, we want another lerp, and we will be lerping. This will be the A input, this will be the B input, and this one here will be the alpha. And now plug this one into the base color, and now you can see we have a outline of dark color. So that looks quite pretty. Like I said, we also want to do the same thing for specular and roughness. So drag in 2 lerp nodes here, and then this one in the A input we want a value of 0.5. So this will be the surface that aren't wet or aren't filled with water. We want another one with a value of 1. This will be the water area. So drag your clamp node from here into your alpha. This will give us a specular of 1 when we have water, and a specular of 0.5 outside of the water. This lerp node will control the wet area, so that where you see the dark color. So drag this lerp node, drag this multiply node into this alpha, and this the output of this lerp into the A input, and a value of 0 into the B input, and then into the specular. And we'll comment it and call it specular. Then copy paste this, because we will be doing almost the same thing for the roughness. Roughness. Sorry. Okay. And of course, we need inputs for the lerps. And then plug it into the roughness. Yes, sorry. The difference between these two is that we want the roughness to be 0 here instead of 1. So yes, we have sharp reflections on the water surface. We have rough specular around the on the wet area, and we have pretty flat surface on the rocks. Let's start making the small waves. So for that we need the water normal texture, and we need the water almost flat normal. Okay. The thing we'll be doing is to distort this image with this one. We'll do this by adding a texture coordinate. We'll be tiling in U4 and V4. Then we want a rotator. Drag your texture coordinate into the rotator's coordinate, and we want a value of 0.2, 0.8, and a speed of 0.01. Then into the UVs. Then we want to copy these two and into the coordinate here, and we'll leave these two like they are, but we want a value of minus 0.013 to give some variation. Now we can add the red channel of this one in here, and multiply them with a value of 0.1. Okay. Now we want to give this one a texture coordinate, so copy paste this one and change the UV tiling to 1, and add this one with this one into the UVs of this texture. So now, even though we can't see it, we've distorted this image. Now we want to lerp, and we'll break the connection of the old lerp up here. So break that one, and we'll use this node for the B input here, and this one will be the A input. Now we want to make a alpha connection, so drag in a add node, or use this one, this doesn't matter. So the red channels, and multiply them by 0.5, and then I will add this multiplier with the green channel of one of the textures, and then send them into the alpha. Let me just make some room here. And for this old lerp, we want to send this connection into the B input. Sorry. We do have small waves under surface. You can barely see them, but it looks quite nice. If you think it's too much, you can lower the multipliers a little bit. Alright. So let's create the big waves. We start off by selecting these two, the albedo map and the mask, copy them down here. We also want to invert the height map like we did before and multiply the height map with a value of 0.7. What this does is that when we add these two, if we weren't multiplying it, we would get the waves to be following the rocks too much, following the height map. But by multiplying it and then add it, we will get a rounder ring. So if you still think the rings are following the rocks too much, you can lower this value and you will get rounder rings. Okay. Now we need to drive this thing with time. A multiplier, and multiply the time by 0.4. And then send the time into a frac node to make it loop, a add node, and we'll add 0.5. And a 1 minus node, which we will be using later on. We'll leave it for now. And then another add node. What we will be doing here is to make several rings. So this over here, we will be making the first ring, and then we will be making several rings down here to give some variation with different speeds, positions, and so on. So drag this add node into this one, and we'll add a value of minus 1.3, and we need a subtract node, and we will be subtracting this one with this one. Sorry, you also need a 1 minus node up here. Okay. So this whole thing here will be the position of the ring. And then we'll multiply it with a high value like we did before to make the ring very sharp, so like 50. So ring thickness. We then want to do some magic here. We want to add a adds node. This will make us a ring instead of what we had up here. Because over here we have like a shape of water. Now we want a ring instead. And if we take a look at the adds node, this is what we'll get. I don't know if you can see it. It's only a few pixels, but we have a ring here. So that's good. Now we want to multiply the... Oh, sorry. We also want to clamp the adds node. Then send a clamp into a multiplier and use this inverter, this 1 minus node that we added before, and connect this one into the multiplier. And then we want another multiplier connected to this one up here, the clamp node of the water area. This will make the rings not, we don't want the rings to go outside of the water, so when it reaches the end of the water puddle it will disappear. And now we want to lerp this thing. So we will be lerping this O lerp as A input, this as alpha, and then we need to make a B input up over here. So we can just copy these three here, copy and paste. The only thing we want to change is the center and the speed in the rotator. So 0.1 for the speed, and then into the B input. Okay, now we can see what it looks like. So drag your lerp into the normal input. Oh yeah, we have to invert the clamp node here, and then into the multiplier. And now we have a ring. So that looks quite pretty. As I said, we want several rings. So this is the first ring. So let's make another one. So copy this whole thing here. So copy and paste. So this will be the second ring. And we want to do one thing here. We want to actually move these a little bit forward. We want to multiply the frac node by a value of 2. This will make the ring go a little bit faster than the other one. Actually, twice as fast. And then we send it into, we want copy these two as well, and into the add node, and then add this one with, no, into that one. Okay. Alright. And then we need an input for this subtract. So drag this one in here. We can change the thickness of this ring, so let's put a value of 70 instead. And then a input for this one, which we haven't made yet. Copy paste this 1 minus node over here. So from this multiplier, connect into the 1 minus node, and then into this multiplier. And then we have to multiply it with the water area, like I said before. And then lerp. So this will be the A input, this will be the alpha, and this will be the B input. And then connect it to the normal. So if you take a look now, we see 1, 2 rings. 1, 2. Okay, cool. And we'll continue making another ring. So copy and paste, move a little bit forward. And this time we can change the speed to 1.5. So from the frac node into that multiplier. And we can change the position a little bit, so 0.4 minus 1.4, and a subtract node over here. Actually, let's make another variation here. So like I said before, this one controls how round the ring should be. So if I lower this value, we'll get a rounder ring. So we'll copy these three here. So this 1 minus node into this B input, and this in the red channel into the add node, and lower this value to say 0.4, and into the subtract node. Now we'll need to connect this one, water area, and we need to lerp the whole thing. So this will be the alpha, this will be the A input, and this one up here will be the B input. So as you can see, we have 3 rings now. Take a look once again. 1, 2, 3. Okay, cool. In the shader you saw earlier, the demo, I use 5 rings. You have to tweak the values so you don't, as you see now, we have 1, 2, 3, and then we have to wait like 3 seconds before we get a new one. So, as I said, tweak the values until you get it right. So now I'll be using the old frac. So into sorry, this one, the add node. In here, we can delete all these. I'll just change the position to minus 1.7. For the subtract, I want the old one. So that will be the add node up here. And then connect this 1 minus node. A lot of wires going on here right now, so I really hope you can follow what I'm doing. So into that multiplier, and the same thing like we did earlier. We copy this lerp. So for the alpha and the A input and the B input, and into the normal. And I hate when wires go backwards, so like I'll do it like this. Okay, let's take a look. So as you can see, I probably only need one more ring to make it not go to make us not wait for the last one. So let's copy it one more time, and then I think we're done with this. So we can use this one again. No, sorry, this one. Into the add node, yeah. No, oh, sorry. Wrong. Down here. Into the add node. And we'll change this one to minus 1.7. No, minus 1.9. Okay. And we'll change the, oh yeah, we haven't changed the size of the rings. So let's do that. 40, and this one was 50, 70, 40, then 80, and then 50 again. Okay. Oh. Yeah. And then for the subtract, let's see what we need here. We want let's use the round ring here. So into the subtract node, and then we'll yeah, we have to connect the one minus node, so let's just find it if we can. I think it's supposed to be this one here. Yeah, to connect that one into this multiplier and multiply this one. And then we'll lerp it. So as you can see, quite many nodes just to make these nice rings. Oh. So let's see. Yeah, now you can see we have. You may have to tweak the values a little bit more, but I think we'll leave it like this for now, because we only have to wait like not too long before we get another ring. And it looks quite nice. So let's continue with the particle systems in a little while. I need a break. So this is the sprite that I use. It's 64 by 64 pixels, and the most important thing to keep in mind is that the particle is the picture is rotated 180 degrees, so the water drop is facing upwards. And let's quickly look at the material. It's very simple. We have the texture connected to the opacity, the alpha channel, and we multiply the alpha channel with itself, invert it, and then into refraction. The blend mode for the material is additive, so by default it's opaque, but change it to additive. Okay, and then I have one for metallic and a low value for roughness, and that's it. So let's look at the particle system. Okay, so what I have here is I used the material, so I won't go through it from beginning to end like I did with the shader, because it's not that advanced. So just add the material that you created. For screen alignment, you want PSA velocity instead of square. Let's go through all the components. I spawn 35 particles, and I have, let's see, yeah, that's it. And for lifetime I have 1. So default values, size is 12, 45, 25 for max, and min is 2, 5, 5. The velocity is 10, 10, minus 250, and then minus 10, minus 10, minus 150. Color you don't have to worry about. I have a light because the problem with the material is that you don't have any specularity. So I fake this with lights. So I spawn lights for every particle. Yeah, I have a white color and a radius of 16 and a brightness of 0.5, and the light exponent is 10. Collision you can delete, I don't use it. And initial location, since I use it with the pipes, it depends on what you use it with, so just do whatever you want. I have 8 for Y and -8 and min and max. Okay, so that's it. Then you can add it to your scene, and let's take a look at the other particle system, the one that's with the impact. So water drops hit emitter is what I call it, and I use the same material and also velocity. Lifetime is still 1, size 10, 15, 10 for max, and 5, 10, 5 for min. Velocity is 100, 150 for max, and -100, -150 for min. I don't use any color, and I have a initial location at 10, 10, 0, and -10, -10, 0. I have a cone velocity with 0, 0, 1 in direction. I don't think I have anything. No. Okay. And velocity by life, I have a curve here. So let's take a look at it. We have the blue channel starts at almost 2, and then it goes down to 1 -1. This happens in 0.3 or 4 seconds. And I believe, yeah, the red and green is at almost 2 all the time, 1.8. Alright, and then you can just drag drop into your scene. Okay, let's take a look at the blueprints, and then I believe we're done. Okay, so you have to make a material parameter collection. I call it water collection. So let's take a look at it. It looks like this. You have a scalar parameters, so you add one of these, and for parameter name you add a parameter in your water puddle shader. So let's take a look at this. Yeah, up here, instead of what we were using earlier, the time, we don't want the shader to be driven by time anymore, so delete these, and then collection parameter is what you're after, and you name it, so water. Now it's connected to that water collection that you created, and then you connect it into the add input, and we will be driving the whole thing with blueprints. Okay, I forgot to tell you this if you didn't know. You make the material parameter collection down here. So new materials and textures, material parameter collection. Okay, but you also need a float curve, so go into here and create a curve, and you have a new curve, and let's call it tutorial curve. Okay, and we'll open it, and it looks like this. So I start at 0 and then go up to 0.26 maybe, and up to 1.25, and then I end the curve at 1.7. Okay. So you can just add new points by holding shift and clicking on the curve like this. Okay. Once you've done that, you can go into your level blueprint. And what I've done here is that I added a timeline. So right click and type timeline, and add a timeline tutorial. And what you want to do here is to click on it, and you get these options. So at first we can use autoplay and loop, and we'll say add flow track, tutorial float track, and you can use a external curve, and that's what we want. So from the content browser, pick your curve. I'll use my old one, which is water curve. And now you see here that you have the curve that you created earlier, and you set the length to I used 30 in the demo. Okay. And then back to the blueprint. And then you want a set scalar parameter value. So set scalar parameter value from the tutorial flow track into the parameter value, and then update into the set scalar parameter value. Okay. And here you see I have used water collection, and you want to do that as well. Now to drive the whole thing, I use the enter key. So this whole thing is to, if I were to put it into play, we would need to hit enter before we play it. But we do have autoplay and loop on, so it will play anyway. So that's one good thing to remember. We also want to set up a matinee. So add a matinee to your level, and this is for the particle system. So if we take a look at the matinee I use, this one. Okay, so we have the drops and the hit. What you do is to right click here and you add new particle group, tutorial, and you select the particle systems in your level and hit enter, and you don't select the trigger, you select on. Okay, and now you can hold control and put it wherever you want, and that's it. Then you can close the matinee. What you do then is to select your matinee in the level, and you right click. Let me do that 1 second. you right click here and you say add matinee controller for a matinee actor. No, sorry, that's the wrong one. Add reference. So you get that thing. And then you want a play node. Oh, okay. You didn't have to insert it. You can just have the matinee selected in the level and then search for play and hit enter. Okay. And then I put a delay. So you just plug this one into your delay, and then the delay into your play. And also, you don't want the enter key into your play anymore. You want it into this play. I hope this wasn't too confusing. Now it should work. So if I use my old one and no, that's not good. I'll use this one. Okay. And now I only want to save. I'm sorry, I had a crash there, so I lost a lot of work, but unfortunately. But if you get into the play mode and hit enter, you should now see the water pouring down the pipes and onto the ground. So I hope that this last part wasn't too confusing, and I hope you managed to follow the whole tutorial. Thank you for watching. Bye.